In this video, I'll be showing you how to create this set of stairs. This is a question that I get often: how do I create spiral stairs and what are the steps involved? So I make sure in this video that I go over the basics of how to get started creating something like this from scratch. I go over exercises and techniques that you can use not only for this design but for many other designs. So I'm very excited to share this process with you so you can learn how the parametric design works. I'll have the script available for you, and if you have any questions, make sure to let me know. I'm excited to share with you the process, so let's jump right in. All right, so the first thing we'll do is create the base geometry. So what we're going to do is to create a point. This way we can always move the location. So we'll start by constructing here a point. So I'll double click, go to construct point. This will give me a parametric point that I can place anywhere in the XYZ coordinate system. Then I like to route it through an empty point component. This way, we can always change that location. So we'll start here and create our base geometry, which is a circle. So we'll go here to a circle, and we'll use the point input as the plane, and the radius will be the inside portion of the spiral stairs. So if on the inside, let's say you want 10 feet, well, we can go here to a slider of 10. But remember that this is the radius, right? So it's a 10 from here, not all the way across. So what we need to do, this way you always know what's the inside diameter, because that could throw you off if you think that, oh, the size is going to be 10 feet. No, well, this is actually 20 feet. So what I do is I go 10 divided by 2. So you go /2, and what it does is it will give you a division component with BS2, and then we can plug in 10 into the input. And so now this would be the diameter of the inside of the stairs. So inside, we'll go caps, inside stair diameter. Now we can move on to creating the base geometry for it. So this is where I would start. Then we would create the actual stair width. So we'll take the circle and we'll go to offset curve. And now it's offsetting it to the outside. So now we can pick a distance. I'll go here to 48.50. And the reason why I do this is so I can have 2 decimal points. And it'll put it at 48.5, which is how wide this is. Now, what's happening here is, let's take a look at the units. We're in inches, so that's okay. So this is 10 inches. So if this is a little bit too small, what we need to do is increase this to something like 100, and then say the inside of this, since we're in inches, it's actually going to be something like 60. Now we can offset by 48. And so that is the width of the stairs. And since we're working in inches, that is the reason why we want the inside diameter to be 60 inches, which is 5 feet, making it 5 feet diameter. So from here to here is 5 feet, from here to here are 4 feet for 48. Now we can create a surface between these two, and that's what we are going to use to create our tread. So we'll take this one and plug them into a component called boundary surfaces. Boundary surfaces will create a surface around a boundary, but what happens is when I plug this one and this one at the same time, they overlap, because when they're plugged in here, they're plugged in as 2 separate curves. So it's trying to create a plane for both of them. When we flatten the input, now it looks at both of those as one, therefore creating a hole on the inside, and we can still change all of the dimensions here. The thing to note is that if you're new, understand that logic kind of goes from left to right. And so the initial circle is a parent object in the sense that when I change the size of it, well, the size of the offset will also change. The thing that's different about this offset that's after the circle, this means that that will not affect this circle. So what happens is, as the wires come to the last component, that is how the logic works. So you go from left to right, and things that are on the right hand side are most likely affected by the things on the left. But the things on the right, when you change them, they won't affect so much of the stuff on the inside. And we can always use all the data that we have here. So let's move on and create our tread. What we need to do is create a line at the start of these two, and then use that to rotate. So we'll take this and this. We'll go here to endpoints. So we want the endpoints of this circle and this circle. So we'll plug the circle into the endpoints, and it's going to have the start and end point be the same. So you have to be aware of that. And also I'll copy this down and do the same thing for the offset. Now that we have 2 points, we can create a line segment, but we need to be careful in the sense that we want to be consistent. So the start point of this inside circle is going to connect with the start point of the offset curve. So we'll go to start and then endpoint. And so we created a line segment. That's where the stairs would start. Now that we have this, then we need to rotate this line segment by a specific amount of degrees to create one tread, and that's all we need. When we create one tread, that tread is what's going to be arrayed all the way around. So we're starting with the basics, with the base model, learning the techniques, and then later you'll see how you can put them all together into your whatever script that you want. So now we can take this, we'll go to rotate, we'll move forward. We'll go to rotate. What are we going to rotate? Well, we know we want to rotate this line because that's what's going to create the tread. Now, by default, these components have an input already set in, and they're in radians. And that's a pain in the butt if you're not used to them and you're used to only degrees. So you can change that by going to degrees. And then plane is going to be what reference plane is it going to rotate it from? Because technically you can rotate it around like this, but it will always use the default plane X, Y. We can change that if we want to by plugging in this point into the plane input. And so now this point is the reference of where that rotation is taken, and it's taken on the XY, which means that it's on the ground. If we wanted to rotate it another way, we would actually have to change the plane. It would have to not be XY, it would have to be YZ or Z or XZ. So with that being said, let's move on to the angle. We can pick whatever angle we want. We can just say 15.50, and I do like to use some decimal points here. And we can just rotate it. But what happens is this will lead us to not an even set of steps to create a 360 turnaround from the beginning to the end. So what happens is I create a division of 360, because what happens is with stairs, since we're rotating all the way around 360, well, we can do a division by 360 depending on how many treads we want. So what I'll do is I'll do that. Let me show you how to do that. It's just very simple math, but it's super useful. This can be used for so many different things. So I'll go here to quotation marks 360. So 360 degrees to go all the way around. Now if we divide 360 degrees, so I'll go / by the number of treads. So let's say I want 20 treads. So I'll go here to 20. So 360 degrees, we want 20 treads. How many degrees would it be if I divided it by 20? So that's what we're doing. 360 divided by 20. Now this is what goes into the angle, because here we'll see 18 degrees. Well, if you're trying to turn around all the way up to 360 degrees, which is the point of a spiral stair anyway, and you divide it by the amount of treads, 20. So let's go here, number of treads. Then we get a degree, which rotates it around to here. And now if I were to take this segment and rotate it 20 times, it would fill the entire circle. So that is exactly what we're doing. It's a little bit complicated if you're not used to it, but I will have this script for you for free and available so you can learn this process, okay? Now with this being said, let's take this, and now let's split them using these. We'll split the surface using these two lines. We'll go here to surface, split, and we'll use the surface input and the geometry as the curve, and also this one, right? Because this is the rotated one, we also need this one. So I'll hold down shift to add another input to the surface split. And now we can move on to, let's keep this here so you can see where things plug in. Now we can disable the preview on everything, because what's happening is now that we split the surface, we're still seeing it before we split it. So we'll go here, middle click, disable preview. We'll take this rotation and lines, like we kind of don't need that, but that's okay, because it doesn't really get in our way. So now with that, we have a surface here. It says 2 values, which means that it's been split into 2 different surfaces. So now if we want more treads or less treads, you can see that it updates automatically. So this is the cool thing about parametric design, is that you can kind of tie numbers together, making it more cohesive. So let's move on. We're going to take this and now extract one of the 2 surfaces. So now let's take this and let's break it up. Let's go here to list item. I just type item and then I look for list item. Here we can pick one of those 2. So what happens is it will pick one automatically, whichever one is index of 0, and we can tell which one is 1 or 0 by doing this. So we have 2 elements here. If I were to bring in an area component and just get the midpoint of these 2 fragments, let's go here to graph. Well, it's getting the center of those 2, so that's not going to work. The idea is that we want to just pick this tread, not the entire thing. So we'll plug in the fragments into the list item. And by default, we have the index of 0 is doing the entire thing except for the tread. Now you can go to index instead of 0 of 1, but we can actually reverse this, because when you only have 2, you can reverse it and get the one that's that you're trying to pick, not the other one. So with that, we have our tread. Let's disable the preview on this stuff. Okay, so we've got a tread. Now we need to array it all the way around. We could go to array, polar, and it can help you rotate things around using a specific angle. So this is a good way if you're fairly new to it, but I want to show you how you can do it yourself by using series, which is the same thing as this. So we'll delete this and start by bringing in a series component. The series component is going to ask 3 things. Where does it start? How much does it step by? And how many do you want? Well, some of those are already answered for us because we know how many number of treads we want, so that goes into the count. The degrees, we know it's 15, so it'll step by 15. And now we can use this output into the rotation. So we'll go to rotate, and we're going to take this item, plug it into the geometry, and rotate it around by 15 degrees 24 times. So you'll see here, the first is 0, second one is 15, 30, 45, 60, 75, and that's by how much it's going to rotate. Now recall that we have degrees here. So if we plug in a radians value, which is by default what it is, then we just need to change it to degrees. And now we've successfully been able to change the number of treads and everything is kind of tied together to 360. But let's say you only wanted to go to 90 degrees. Well, you can change it to 90. And now we're only rotating 90, but our treads are too small, so then we would actually need less treads. So this angle becomes critical for creating spiral stairs here inside a Grasshopper, so we can now have at least the base geometry, which is taken care of by splitting an entire ring into the tread. The tread is then rotated around 360 degrees 32 times to complete that 360 degrees. Perfect. So if it's a little bit confusing, I would suggest just give it a few tries and see where you have issues. And then if you have questions that maybe I haven't answered, maybe you haven't thought of, send them to me, either to my email or to anywhere here, and I can answer them for you. So I'll disable the preview here. Now we can move on to creating the vertical rise. All right, so at this point, we got most of the stuff. Now the only thing I haven't relabeled here is going to be stair width. Okay. Now what we need to do is the same thing that we did with series, because we know how many number of treads we want. So now we need to move it up vertically by 32 times by specific height. So series is exactly what that's used for. It's, for me, one of the most useful components. So we'll start with count. Well, we know how many treads we want. Step. By how much are we going to go up? Well, we'll say 6.500. Where is it going to start? At 0. But let me show you how that one can be very useful in this case. So we'll take the rotated ones and we're going to move them up. So what do we need to bring in? A move component. We'll move all of those up by 6.5 each. So we'll go geometry into the geometry input. The motion, unit Z. And now it's going to be moved up by, so if we only have one slider here, let's say 6.5, well, they would all move up by the same amount because it's only one value that it's moving up. Here we have 0, 6.5, 13, 19. So progressively it's going to go up. That is what we need to use. And what happens is I did not plug, so when I plug it right in, it's a bunch of numbers into the motion, but the motion needs to have a specific vector. So we need to move it up in the Z direction. This is why that didn't work. Now here we have the ability to create a step of 6.5. Then this one from the ground goes up by 6.5 times 2, 3, 4, 5, and so on. Let's go back here. Let's go to a smaller count. 20. And the reason why I picked 20 is because 20 code in the United States is the maximum number of treads that you can have before you have a landing, or 10 feet vertical height before you have a landing. So spiral stairs, if they're trying to go up more than 10 feet, they would need to have a landing. So this is where there are additional things that we could do to array this up and create a landing. But the idea for this is to get started and show you how some of these simple steps can end up creating some of these very complex designs. Let's go back here. Now we have the amount 6.5. We can say 6. And now we don't need the bottom copy. So we'll go back here to our surface, our boundary surface, and our subdivided rotation. Disable preview. Now let's go back and look at our dimensions. So our inside diameter, if we have it at 0, it will not work. So you would have it at a very small, and regardless, let's say if you had a spiral stair like this, well, sometimes you would actually have a structural column going up here, and that's what supports these treads. So you would always have a small small amount here. It wouldn't actually go to a point. That would be actually structurally wouldn't work. So this is how we can change this to, let's say, 60. For 60 is going to be 5 feet from here to here. We can always increase this also. Then we can go stair width. It's going to be also by code 36-inch minimum. Let's move on here to number of treads. The more we have, actually, we increase a higher number. But like I said, we do have some code restrictions. We'll go here to 20. If we don't want to rotate all the way to 360, we can go to 90. And I can also have this as a slider. So right now I don't have it as a slider. I have it as a panel. We can always change that. So let's go here to create a custom slider. We'll go 0 dot 360 dot 720. This way we can change this to be from 360. It could even go more, or it can go less. 360 is typically the normal one, but we can also do 180, which means it just goes, let's say, from here up to the second floor. Tread height, by code, 6 inches for commercial, and then you can go up to 7 inches if more, or 7 inches and more if you're in residential. Now the other thing that I was going to mention is this is the tread height, and technically if we were to look at this, this tread is on the ground, and if we were to extrude it, that's not where it would start. It would actually want to start up at this level. So what we need to do is, when we create the array up, the start point is at 0, which means that when you create the series, it starts at 0. So how do we make it so it starts at 6? Or at whatever value the tread is. 6 here. Well, this same input, the output is going to be into the start number, which means that it starts at 6 and then progressively goes up. And this is more of what we expect to see when we do spiral stairs. And also one of those rare cases where you actually do have a start point that is different. Typically I use it when start point is going to be 0, like when we do rotation here. And that's because you don't want to start from a rotation that is a different rotation. You want to start at 0. So that, every case is going to be different depending on what you're trying to do. So with this, let's create the thickness for the treads. What we'll do is we'll take this and we're just going to extrude each one of those up. So I'll go here to extrude. We'll take the treads into the base input, and now we're going to extrude it up. So when we extrude or move something, we need a direction. We'll go to unit Z, plug that in, and now we can pick a value. We can say 1.5. And that will give me a slider from 0 to 10, put it at 1.5. But what happens is we need to extrude this, not up, because then that would make our tread larger from our spring point. So Z, but negative. Now let's do this. So now that we've done this, I want to show you how to make it a little bit more structural, because right now we just have these floating around. So what we're going to do is take the inside portion of the circle, we're going to offset it and create a wall that goes all the way up past the treads. So what we need to do is take the initial circle, we can either go to boundary surfaces to create a surface right on the inside of that. And now we can extrude that surface up all the way to the top here. The way to calculate how far did we go up, because we did it in steps. 6 multiplied by 20. 6 inches for 20 treads. So I go here to a multiplication. So I'll go to a star, enter. You can always go up here to math, multiplication, and bring it in. And we'll do 6 times 20. This is going to be 120, which is the direction that I want to extrude this up by. So I'll go here to unit Z and the vector into the direction. What we've done is we just extruded it up to that point, and from there we can extrude it further to, let's say, create a, when you come up, that it doesn't just end here. I think it looks a little bit awkward. We can extrude it further by adding to it. So this is another great way in which using simple math here is super useful. We have 6 times 20 plus, this is how we're going to extend this, plus whatever amount. We'll just say 60 for 5 feet. Then, since the output was 120, now it's 180, and I have to override that so it works. And now this becomes from 0 to whatever height is going to be, I'll just go 36 here. Okay. So that is how we can create kind of that structural wall on the inside, but it is just a solid wall. So if we wanted to make it into a hollow one, this is what we would do. We would take that initial line, we would offset it. So I'll go here to offset curve and offset this circle to the inside. So I'll go here to a negative component because the positive one is going to the outside, so the negative one will go to the inside. We'll go 1.500. And now when we take this and actually, so we have this surface before. Well, we want to create the surface between these two. So I'll take this and create a boundary surface to override. So I'll plug this one, and holding down shift, I'll also add this input. Then, since they're overlapping, like I mentioned earlier, we need to flatten it so we only get that, and that is what we override. So we'll delete this and we'll use this to extrude it up. So this is a cool way to offset some geometry to give it a little bit more of a realistic structural look. So we'll go here to 5.5. And all of it is tied together like this. We're going to go. So that concludes the tutorial. This is more of a general overview on how to create spiral stairs using series and rotation and circles here. From here, I don't know if you guys have seen my scripts and stuff. Some of them can get really complicated and complex as we move forward because we always start from general and go to specific. So this is more of a general design that anyone getting started can learn some techniques to use later on. You can take this, middle click, and then bake. And from here, we can go further into, let's say, doing more hand designing. So I'll just go here to shaded mode, and we can just go to a new layer, go to an interpolated curve. I'll go here, interpolated curve, and I'll just pick the outside points. Now we can do this parametrically, but if you're fairly new, it's okay to do this. It's okay to do the heavy work inside of Grasshopper. And then when you already have what you kind of want, you can further develop it inside of Rhino, knowing that most of these steps that we took to create this are perfectly accurate because we made sure to do all of the steps using sliders. So there are no issues here. So I'll take this, move this down a little bit, past the treads, and then I'll go here to extrude curve. And I'll go past that rail here, like this, creating a side rail. And now we'll take this, we'll go here, sweep one, select the rail, this one, shapes, this one. So it'll finish it off here at the top. We'll join it, offset surface, and we'll say 3 inches. And so we've created kind of this spiral stair set like this with a small inside diameter that we can always change. We can always go here and update that inside diameter. So with that being said, make sure to check the files so you can follow along with me and not, and if you have any questions, you can always send them to me, but that should help you out a lot. Thank you very much for being here. Hopefully that was useful, and stay tuned for other videos that will help you get ahead with parametric design and just gathering more skills to become a better architect. Thank you once again, and I'll see you next time.